Hello and welcome to section 4.2. We're continuing our discussions on systems of linear equations. And in this section, we're going to concentrate on what's called the addition method. So the first question, of course, is, well, what is the addition method anyways? Well, in some cases, let's take a look at this system of equations that we have right here. It's not exactly easy to isolate one of the variables in terms of the other without getting a lot of fractions and other things that people really don't like. And believe me, if you're not a fan of fractions, you will not be a fan of using the substitution method with either one of these equations. However, the addition method gives us the ability to solve the equations a little bit more directly. And if you look at these two equations right here, something should suggest itself to you right away. You see what I mean? In this case, the addition method, we combine the two equations in such a way that when we add them together, then one of the variable terms is eliminated, allowing us to solve for the remaining variable. This is a method based on the addition property of equations, which says if we do something to one side of an equation, we can do exactly the same thing to the other side of the equation. So it's almost as if we could just add something to both sides of these equations. Well, we can add these two equations simultaneously because if we look at the result that we would get, the solution almost presents itself. It's so we could take 5x plus 2x and get 7x. We could add negative 3y plus positive 3y and get plus 0y. And 14 plus negative 7, which would give us 7. And that's pretty convenient, you might say, because in this case, the 0y is just a term that goes away, and we're left with the equation 7x is equal to 7. Now, how useful is that? Well, of course, now all we really have to do is divide both sides by the constant in front of x, and we get x equals 1 as one of the solutions to this system of equations. Now we could do just like we did before with our method of substitution, choose one of the two remaining original equations and substitute in 1 for x and find the value of y that goes with it. So let's try this out. Let's say I put in 5 times 1, replacing x, minus 3 times y, and set that equal to 14. Now, if we simplify this equation and solve for y, 5 minus 3y, and that should be 3y, will equal 14. I would subtract 5 from both sides. Subtract 5 from both sides, and find that negative 3y is equal to positive 9. So divide by negative 3, and you get the y value of y equals negative 3. Okay, so our solution is the ordered pair 1, negative 3. Right? Now you notice that what we did right here, this was very convenient for us. We were able to add these two equations directly, and we can see that this result. Well, why could we do that? If we're solving for a common value of x and a common value of y for these two equations, then all we're really saying is that whatever value of x solves both of these equations, whatever value of y solves both of these equations, we add these two together, this is going to result in that solution. And we can check by substitution the point 1, negative 3. And if we take 5 times 1 minus 3 times negative 3, we should come up with 14 if we did this correctly. And of course, we do, because 5 minus 3 times negative 3 is plus 9, does equal 14. And that's true. Taking a look at the other equation, 2 times 1 plus 3 times negative 3 should give us negative 7 if we're correct. And of course it does, because 2 minus 9 does indeed equal negative 7. So we're all set with that one. Next example in the next video.